Hey guys, welcome to lesson 2.6, solving quadratic equations. Let's recall that in general, a quadratic equation in standard form looks like this. So everything is on one side of the equal sign in descending order of exponents for your variable x, and then the other side of the equal sign equals 0. Now, to solve a quadratic equation, there are lots of different ways. Our first go-to should probably be factoring. It's the quickest, however, it's not always possible. So, if it's not possible, we end up trying to do the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. The next option is by graphing to see where your graph touches the x-axis. And the last option is completing the square. So we'll go ahead and do an example, something that you've already seen before and are used to. Again, when I say solve, you are looking for the roots of the equation. So what we're going to do is we need to put each one of these quadratic equations in standard form. So x squared minus 5x, and like I said earlier, it must equal 0. So I'm going to bring this 24 to the other side, and then now our equation is in standard form. So let's go through the motions. We'll try factoring because that is the fastest. Think of two numbers that multiply to 24 or negative 24 and add to negative 5. And those two numbers would be negative 8 and positive 3. But we haven't solved yet. What we have here are factors. These are not the roots. The roots come from letting each bracket equal 0. So x minus 8 equals 0. So that tells us that that x equals positive 8. That is a root. Again, if x plus 3 is set to equal 0, then x minus 3, or x equals minus 3, is the root. So on a test, if I say solve, I don't want you to stop here. I want you to go ahead and tell me, what does x equal? Let's move on to another example. Check to see if we can common factor, which we can't. I have 3 terms, so I'm going to see if I can think of two numbers that multiply to negative 6 and add to 4. I can't think of those two numbers, so this is not factorable. So what we're going to do is implement the quadratic formula. So again, just to remind you, the formula is negative b plus or minus the square root b squared minus 4ac, all divided by 2a. So when I'm filling this out, it should look like negative b plus or minus the square root of 4 squared minus 4 times a times c, all divided by 2 times a. And when we simplify, we end up with 16 minus negative 24, all divided by 4. Cleaning it up a little bit more, 16 plus 24, so we end up with square root of 40. Now, this is not fully simplified. Remember in grade 11, when you worked with radicals, you need to simplify your radical. So when you're doing this, I want you to think of two numbers that multiply to 40, one of which needs to be a perfect square. So for example, square root 4 and square root 10, when I multiply those, it gives me square root 40. And the reason I picked 4 and 10 is because 4 is a perfect square, and I know the value of this. This simplifies into 2 root 10. So for example, if I picked 2 times 20, neither of those are perfect squares, so that's not going to help me simplify. So when you're working with radicals, find two numbers that multiply to the inside number. One of those numbers must be a perfect square. Anyways, so we'll continue now. X equals -4 plus or minus 2 square root 10 all divided by 4. Now, before you go ahead and start crossing things out, this is the step where I want you to cross things out. I know a lot of people will cross out the 4 here and the 4 in the denominator, and that's not going to work out because you must factor before you cross out. So I look at the numerator and I see I have a term of -4 and I have a term of 2 root 10. So I know that 2 is common to both terms. If I factor out a 2 from the numerator, I am left with -2 plus or minus just root 10. Now keep in mind the numbers on the outside of the radical are different from the numbers on the inside of the radical. So when I go ahead and factor, I'm only factoring the numbers on the outside. This root 10 stays as is. And because I've factored, now I'm able to reduce and simplify. So I can take the 2 and the 4 and reduce it. So what we're left with is -2 plus or minus the square root of 10 all over 2. And again, you can't reduce here because the value on the outside here is 1. When you're dividing, this must be divisible, or this must divide into both terms. So by crossing this out, you have not divided this term by the 2. So keep that in mind. This is the simplest radical form. And this is as far as I want you to go on a test. Okay, let's continue. So now we're going to talk about quadratic equations that have complex roots. So for example, in grade 11, if I asked you to solve the following equation, x squared minus 2x plus 5, you would say, okay, well I can't factor it, so you put it into the quadratic formula, and then you notice that when you're working through the quadratic formula, you end up with a negative inside a square root. And then you would stop because you say, oh, you can't square root a negative number. This equation actually does have roots. They're called complex roots. So what I want you to do is highlight the fact that I equals the square root of -1. And if I were to take this and square it, so if I squared both sides, then I squared would be equal to just -1, because the square and the square root cancel each other out, and we're just left with I squared equals -1. So keep that in mind as well. Put a little star beside it, highlight it. Complex number has both real and imaginary parts. So A plus BI. So A is the real part and BI is the imaginary part. So for example, 5 plus 2i is a complex number. 3 minus 7i is a complex number. 6i is a complex number. So if we were to continue on from the question above, we would want to think of two numbers that multiply to 16, but we have to keep in mind that we have that negative there. So -16 breaks down into square root of -1 and then square root of 16. I know that the square root of 16 is 4, and I know that the square root of -1 is I. And that's how we are going to write this. So 4i represents square root of -16. So from here, I would see if there's anything common in the numerator, which there is, so I'll factor out a 2, and I'm left with 1 plus or minus 2i all divided by 2. Now that it's factored, now I'm allowed to reduce. So I'll reduce the 2's, and what I'm left with is 1 plus or minus 2i. Again, a complex number with a real part and an imaginary part. Okay, so we'll try another example. 3x squared plus 5x plus 4. I can't common factor. I'm stuck with a complex trinomial, and I want to see if I can find two numbers that multiply to 12 and add to 5. Can't think of those numbers, so we'll go ahead and do the quadratic formula. X equals negative b plus or minus b squared minus 4 times a times c. So we end up with 48, all divided by 2 times a, so 2 times 3 is 6. So we'll simplify a little bit more, and we end up with the square root of negative 23 here. And we want to simplify this so that we're not dealing with negative square roots. So again, square root 23 can be broken down into negative 1, and if you can think of two numbers that multiply to 23, one of which being a perfect square, you can do so, but in this case 23 is a prime number, so the only way you can multiply it is with 1 and 23. So we'll go ahead and simplify as much as we can. Negative 5 plus or minus I root 23. I because of the negative 1 being square rooted. All divided by 6. Now there's not much more you can do up to this point. Taking a look at the numerator, there's nothing I can factor out that'll help me reduce, so this here would be our final answer. So we'll work a little bit now with complex numbers. Adding and subtracting is just like working with variables, so you kind of work with them separately. If I asked you to simplify this, well, there's a positive 1 in front of this bracket and a positive 1 in front of this bracket, so when we distribute, we end up with that, and then you're just collecting like terms. So 5 plus 4 gives me 9, and negative 2 plus 1 gives me negative 1i, and that's it. So we'll try one more time. Positive 1 in front of this bracket and a negative 1 in front of this bracket leaves me with negative 8 plus 3i. So numbers collected with numbers leaves me with negative 1. 2i plus 3i is just 5i. Multiplication, again, same as working with variables. So we would just distribute this 4 inside the bracket, leaving me with 12 minus 8i. And that's it. Nothing else you can do there. When you are working with a binomial times a binomial, it's the same as if you were working with variables. So just do the normal distribution. 2 times 3, 2 times positive 6i, negative 5i times 3, and negative 5i times 6i gives me negative 30i squared. So again, we'll collect like terms. 6 minus 3i minus 30, but remember what we said a few pages ago. I squared was equal to negative 1, so we are going to sub that in. So this ends up being negative 30 times negative 1. So what we end up with is 6 minus 3i plus 30. So final answer, after we collect like terms, would be 36 minus 3i. Okay, and one last example. What we're doing here is multiplying something called conjugates. Now, what a conjugate is a binomial. So, for example, 1 plus 4i, and in another bracket, you have pretty much the exact same binomial, but the opposite sign. So let's see what happens when we multiply conjugates. We'll do the distribution. So 1 times 1, 1 times negative 4i, positive 4i times 1, and then positive 4i times negative 4i gives us negative 16i squared. Now, the special thing about conjugates is take a look at these two middle terms. Once we go ahead and simplify, well, negative 4i plus 4i cancel each other out. So all we're left with is 1 minus 16i squared. But again, remember that I squared is equal to negative 1. So we need to fill that in and simplify. So this really ends up being 1 plus 16. So final answer is just 17. So if you notice, when you are multiplying conjugate numbers, our final answer ends up being a real number. Okay, so we'll go ahead and do a little bit more work with negative radicals. So we'll start with negative 50. Remember, you want to think of two numbers that multiply to 50, and one of which needs to be a perfect square. So for example, negative 50 can be broken down into negative 1 times 25 times 2. And the reason I picked 25 is because I can figure that out in my head. The square root of 25 is 5. So what we end up with is 5i because of the negative square root 1, and then just root 2. And that's it. When you are adding radicals, it's very common to adding variables. You need to have like terms. So that, in other words, the number inside must be the same. So we'll do a little bit of simplifying, and then we will see if there's any like terms. So breaking down the root negative 18, I would pick negative 1 for the negative sign, and then 18 can be split into 9 and into 2. I wouldn't choose 6 and 3 because I don't know the square roots of those off the top of my head. They end up being decimals. So 9 and 2 work out great, because this would simplify into square root of 9 is 3i root 2. Now let's work with the root of negative 8. Negative 1 for the negative sign, 4 times 2. So that would simplify into 2i root 2. So now we have like terms. Because both of these have a root 2 in it, I can add the numbers on the outside of the radical. So keeping the root 2, I have 3i plus 2i, and that leaves me with 5i. So that's it for today's lesson. If you have any questions, make sure you ask in class. Take care, guys.